Good morning, everybody. This is Bill from AT Makers, and I am delighted to be joining you today at the Pennsylvania CS for All Summit. I'm going to be talking for about the next 20 minutes. I hope I can cut this down to 20 minutes, and then I'll be taking your questions afterwards. But I want to thank you all. I want to thank the folks who invited me to join you. Also, thank you all for considering how AT might be involved in your computer science plans. And I hope that you'll get something out of this quick presentation. Before we get started, I do have a few disclosures to make. I am the co-founder with my wife Lori of Lesson Picks. I know some of you in Pennsylvania, a lot of you in Pennsylvania use Lesson Picks, which is great. I'm also the founder of atmakers.org, which is a nonprofit charity based in Florida. We are focused on bringing together makers and AT users. A couple other things that I have done recently. I'm a mentor on several FIRST robotics teams. And I just founded COVID Speaks with COVIDspeak.org with Brian Whitmer from Cough Drop to provide an AAC solution for people who are intubated or otherwise unable to communicate during COVID-19. Now, unlike most presentations, it might be important today for me to go a little bit into my background. A lot of times people don't care about my computer background because I'm talking to AT folks or to educators. But in this group, it might actually help for me to have some credentials as far as computer science goes. So I graduated in '93 from the University of Florida, go Gators, with a degree in computer engineering. And then I went to work in industry. And over the next 20 years, I worked for a variety of big firms, Fortune 500 firms, as clients of Perot Systems. So Ross Perot's consulting company. I worked there for 15, 16 years, and then another few years in other consulting organizations. But it gave me an opportunity to spend about a year and a half to 2 years on projects that were pure development projects. So I worked for AT&T, the Chicago Board Option Exchange, the London Clearing House, a whole ton of companies. And I spent a lot of time writing software and then later mentoring other programmers and leading offshore teams. I straight up did the developer thing for about 20 years, 15 with Perot. When I was ready to be done with that, I worked with my wife, Lori, to found a company called Lesson Picks. And a lot of you may know Lesson Picks. Pennsylvania is one of our largest states in terms of adoption. And thank you for doing that. But Lori is a fantastic artist, and I could write code. So if you've ever used Lesson Picks, I wrote everything that runs that site. And it's grown to be something fantastic. Right? We are over 40,000 users at this point. And it's running wonderfully, running well enough that we were able to start this charity. So almost all of AT Makers is funded by, in some way, through Lesson Picks. That's not quite true anymore. We get about 20% of our money comes from other donors, but this is definitely made possible because of Lesson Picks, and I'm delighted that we were able to do it. I say in there that Lesson Picks introduced me to AT and made me grumpy. And I'll explain that in a little bit. But it definitely did drive towards the creation of this charity. To get started, there are a couple of definitions we want to make sure everybody is on the same page on. The first, probably really important one, is what is AT? What is assistive technology? AT is any technology that helps users perform everyday tasks. Of course, that means everything, a keyboard, a mouse. So that's not really it. Everyday tasks, in this case, are really things that most people don't require technology to do. So walkers, power chairs, adapted keyboards, adapted toys, things that are not normally accomplished through technology, but some people need technology to do them. That's really kind of, in a nutshell, what assistive technology is. I have some examples on the left here, on your right here, sorry. And you can take a look at them, but it's kind of a big gray area. Really, AT is what gets funded as AT. And it's really kind of, you'll see in a minute, that's very true. But what we're talking about here is things that allow people to do everyday tasks who normally are not able to do them. Perhaps as importantly, a second question would be, what's a maker? Some of you may not be familiar with the maker movement or makers in general. You can read a great book by Dale Doherty called Free to Make. I'll be happy to provide a link somewhere in wherever you're seeing this video. But he didn't invent the term, and he didn't invent the movement. He just documented it pretty well there. The idea of a maker is somebody who gets more value from an object that they create. And there are a lot of makers in the audience right now. Anybody who's ever sewed from a pattern or quilted. There's a lot to people who make the materials and the items that they want rather than consuming them. It's kind of the opposite of a consumer. In our case, they are the kind of people who can make a custom device to fit somebody. Very often they have some of the things that we're going to talk about today. They know how to solder. They know how to do basic electronics sometimes. They don't mind getting their hands dirty. And in many cases, they know how to code. So with that background, why do I want to bring these two groups together? The shortest version of saying that is basically, I got really grumpy when we started Lesson Picks because I would go to AT conferences and I'd walk around the exhibit hall where they're showing products. And I'm an engineer, so my brain is trained that as I'm walking around the hall, I'm doing a bill of materials in my head and trying to figure out what would it cost me to make that. And things didn't make any sense. Items that I figured I could probably make for $40 or so were costing $800. Tablets were costing $8,000. Things didn't make any sense, and I got really kind of grumpy. One of the things I didn't mention earlier is, in addition to being an engineer and being in the AT space, I am also the parent of a child with special needs. And I was not okay with this. I was very much not okay with this. And I started looking at what was wrong with the AT industry, how it was broken, and how I might be able to help. And I did find a way where I think I can help. So when I say that AT is broken, the biggest thing broken about assistive technology is the funding. In 2001, the folks in AT at the time reached out to the federal government and quite correctly tried to get AT funded. There's nothing wrong with the request or anything else, but what it has created is something that is a little bit warped. You all are computer science teachers. Some of you are computer science teachers. Those of you who are probably know what Moore's Law is. For those of you who don't, Moore's Law is a rule of thumb, coined by Gordon Moore from Intel in the 60s. Basically, it says that the number of transistors on a given amount of area is going to double every year and a half. What that translates to is every year and a half or so, the price of an object, a technology object, whether it's a phone or a television, is going to get cut in half. That's been happening since the 60s. It continues to this day. And one of the interesting places that it's not happening is AT. When things got funded back in 2001, prices were set. So, for example, a speech-generating device that was priced at the time at $7,500, which is a little bit high then, is still $7,500 in 2020, which is kind of crazy. That's 20 years. That's many iterations of Moore's Law, and none of them have taken place in this community. It's something that I don't think it's going to be easy to fix that politically. It would require a politician or somebody appointed by a politician to say, let's spend less money on special needs kids. No matter where you are on the political spectrum, you're going to lose the next election if you say that out loud. So I don't think there's the amount of background necessary to fix it from the top. So we started looking for things bottom up. I think there's room to improve here. Now, the fact that the pricing is broken or out of date or hard to fix may not lead to bad products, but it kind of does. It leads to a market that is not functioning well. So good vendors, and nobody is evil here. I used to think people were evil when I was very grumpy. Nobody's really evil here. They're working in a system that is fundamentally flawed. But good vendors in this space, they can no longer compete on price, availability, or features because all of those are defined in the law. So they compete on outcomes. They compete on making sure you get great support. You get speech pathologists as your sales personnel. So the good vendors in this space are focused on their end users, but there is no competition on price. There is no competition on features. It is very slow to add new players to the market. It's very easy for new players to get gobbled up by established players, and fundamentally, it's broken. A lot of the time, a large percentage of the money from these devices goes back into getting users funded, which basically means making sure that the politicians continue to spend the money on these devices. So I have always had this slide, minus the red X, in my presentations. And those of you who saw me at the Helix conference may remember this slide. How do you fix this? I have no idea, but stop acting like it's normal and realize that you have other options. Now, when I'm talking to AT folks, this is what I focus on. But I really do have an idea now. At this point, I have a really good idea on how to fix AT, and it really does drive what the purpose of AT Makers is. This is how we fix AT. We engage the next generation of makers. We engage the folks who are currently in high school or college, who have never heard of assistive technology. They've never spoken to somebody who uses a speech-generating device. They've never had to work with a child who's on a ventilator or a CPAP device. We get these kids engaged now, and we get them to understand you can make a difference today in this space, and when you grow up, there is a market that desperately needs you to be involved in it. And this is completely working. I am so thrilled with how this is working right now. It is not the case that AT Makers is about getting computer science in schools. It is necessary for computer science to be in schools in order for us to succeed. So as I go forward here, realize that I'm behind you. It's not our mission, but we absolutely need you to be successful in computer science in order for us to do any of the things that we're even doing today, let alone what we want to do in the future. So the kids you see behind me are aged between about 12 and 22. They are primarily from robotics clubs or from college groups, individual college groups. Some of them are founded, like Women in Computer Engineering is up there. Others are pure FIRST robotics teams, like Roaring Riptide and Gravy and Exploding Bacon are all up there. These are all teams that work within the FIRST robotics competition or FIRST Tech Challenge group, which was founded by Dean Kamen. These kids already are organized. They already are teaching themselves or are being taught computer science and robotics and electronics, and we are able to work with them to provide an outreach program. Now, I'd like to show you probably our first success story, which was done with Team 135 in Indiana, which is Ella Hunt, a little girl, who needed help with her power chair.
Together. That's beautiful.
That is fabulous.
That's fantastic.
That is fantastic.
Okay, can you get yourself turned back around towards Dennis?
A little more. It's. You got it.
Just figuring out
the timing.
All right, ready to go to the mall?
This is the Penn High School team that has been helping work with us on better hand positioning. They've also been helping with some programming on her Switch. She's doing awesome. So today we put new, they designed little troughs to help hold her hand in because they were falling off, and a better way to hold her switches. She comes over here, I think. Hey Ella, can you drive right up to me so I can show the camera your switches? Now we didn't rebuckle your seatbelt, so no accidents. Okay, very good. Very good. Are you liking it? Are they doing a good job? Cool. Nicely done, Ella. Yeah, you can go. Yeah.
So as you can see there, that was kind of awesome. Little girl, Ella Hunt, had SMA type 1 and couldn't drive her power chair. And she was informed by her power chair company that there was not a device that would give her the control she needed. She basically could only move one finger on each hand, and that wasn't considered enough to drive the chair. I worked with a maker in Maryland named Jonathan Lasco, he and I worked out a plan for how we could map those two inputs she has to driving the chair effectively. And then we created a device that controlled her chair. We reached out to Penn Robotics in Mishawaka, Indiana, to help be her pit crew. So we created this device, but it needed to be reprogrammed periodically and updated. She needed to have the troughs made to hold her hands in place. They built a ramp at her house. A lot of things happened with Team 135 to help Ella with all of the technology and other supports that she needed. And it was a great partnership. And I like this picture, the picture behind me. I show it a lot. I probably show it at every presentation I can because I love what it says about the outcome of what we're doing. Everybody sees the benefit for Ella. It's easy. She can drive a power chair. It didn't cost her a fortune. But all the other people involved get at least as much out of this. So you can see, I hope you can see my mouse moving. You've got Ella here in the center. This is her physical therapist and her mom, Erica. In the back, you've got these two kids that are taking pictures with their phones. And they kind of represent something important. First has a really great setup where in order to be an A team, in order to go to the World's Championship in Houston and Michigan, in order to win the competitions, it's not just about what your robot does on the field. It's also about what you do in your outreach program. And it's about how well you take what you're learning in the STEM program and expand it outside of that into your community. And so these two kids in the background here are actually documenting this in order to compete for their Chairman's Award and to show off and put it on their social media for their team. They are getting something out of this that feeds into the program that they're in. My favorite person in this picture, however, is this woman right here. Now, this is Italia Fields. She's in college now. At the time, she was 17 years old, a junior at Penn High School. And she's playing tag with a girl who has SMA type 1, who is in a power chair and probably always will be. Italia is looking past a CPAP across her face, all of the equipment that surrounds Ella, and is seeing a little girl and playing tag with her. They set up a space in their robotics room where they normally set up the championship court and practice, and they let Ella use it to learn how to drive her chair. Everybody is winning here, right? Everybody here is going to be a little bit better. Italia is going to be a much better human for the work that she did with this project. So I'm sorry about gushing over this picture, but I love it. These kids are going to be better off for what we're doing, and I love that we can get them involved. So with your permission, I'm going to show a few more examples here of what we've done over the past few years and kind of show where we're going with this. Now, some of you may recognize the device at the center of the screen right here. This is an IntelliKeys keyboard, and if you've been in special education for a long time, you've probably used one at some point. These are fantastic tools for folks with cerebral palsy and other things as well, but it really took off in the CP community. And there are folks like Jefferson on the right who, in their lives every day, not in school, use these devices because they are the most effective thing for them to use to type and communicate. Problem is, they haven't been made in the last 10 years, and they haven't been supported in the past 5 because of the way the AT industry has worked. They got purchased by a company that didn't find a market for them, and so they stopped supporting them. We worked with Roaring Riptide, which is a robotics team in Gainesville, Florida, to kind of try to rescue them. So we got the software made open source by the company that had bought them, AbleNet, and then we got a release of that software out. Then we actually made an adapter that allows these to act like normal keyboards. You can plug them into any device. And what's great about this partnership with Riptide is they have not only taken on the act of making some of these things for us, they're managing it. So when somebody needs one of these and asks for one through the AT Maker site, that goes directly to the teenagers who make one, test it, put the latest software on it, package it, mail it to the end user, and then support them. And this has become a big outreach program for them, and one that we're really proud of. This is taking a piece of technology that was dead. Many of them have been thrown away, unfortunately, and they're not broken. These things are made like tanks. They're going to last forever. But the software isn't, and they need to be updated to work with the latest operating systems. They need to be able to continue to work with new devices like Androids or iPads. And we're able to do that by moving the software into this little adapter. It has been a fantastic project. Riptide has been great for a lot of our projects, and are one of our best partners. But if you read the note in the upper right, Jefferson is just thrilled, right? This is a tool that he has motor memory on, and he hasn't been able to use it on his new Mac since he updated to Mac OS 10.05 or something. It is a huge impact in his life, and it is great for these kids to see that the software they're writing, the devices they're manufacturing, the support they're giving are having an impact in their community. We've also partnered with another robotics team called Gravy out of Orlando to make this device called a Freedom Wing. This is a project that was originally requested by Able Gamers, which is a charity that helps people who have profound physical challenges game. So they get them into Xbox gaming or PS4s or online gaming or handheld gaming, whatever it is that they're trying to get into. They have created, Able Gamers has created a system where they can get evaluated, get custom devices and things like that. Steve Spawn, above me in this picture, reached out to me and asked for a device that would allow folks to use their power chair wheelchairs to control a game instead. So you'd unplug it from your power chair, plug it into your Xbox through the adaptive controller, and it would just work. This would allow people to not have to learn how to move. They already know how to move their power chair, use the same controls, the same buttons, the same joystick that they have already in place to control their Xbox. So we created one. We work with Gravy in the robotics team in Orlando. And like the IntelliKeys adapter, these kids have taken on manufacturing and distribution as well as the actual coding and creation of the devices. This is really good for the kids. It means in addition to seeing their work out there, they're learning how to do design for manufacturing. They're learning how to do testing. They're learning how to do customer support, which is huge, right? They're going to enter the workforce with experience that most people don't get until they're 30 to be able to support a product that they've created. It is huge for them, and we're delighted with the way this is turning out. We've now found that device is not just for controlling a game. It's also become a mouse. It's been able to fly a drone. We can do all kinds of crazy things with exactly the same device that we designed with Gravy. And finally, this is not a separate project, but every year for the past 3 years, we have had these robotics teams come down to Florida in either late January or early February to the ATIA, which is the Assistive Technology Industry Association convention in Orlando, Florida. So they come down and they help me and other makers run the Maker Day at ATIA. And this gives them the opportunity not just to talk about what they did and show off a little bit, although they do that. They also get to teach the people who are attending the conference how to solder, how to adapt a toy, how to use Instamorph. They get to show a lot of things that you would think the education would go the other direction. You would think that we're inviting these teens to go to the show and they're going to learn about AT, and they do. But they also bring what they know to an AT conference where very, very few people are actually technologists. They have ATPs, and ATP is an assistive technology provider. They generally are not from the technology space. They're occupational therapists, they're physical therapists, they're SLPs or other teachers. They're very often caregivers. They're not usually engineers. And to see a generation of young engineers come in, future engineers come in, and help teach them. You can see right here in the center of the screen, these are two Riptide kids teaching two special ed teachers, I think they're special ed teachers, how to solder. And it is a great experience for them to see that what they know is valuable and that they can actually share it with the world. So as you can see, these projects give a deeper purpose, a deeper sense of purpose today for what these kids are doing. They love the fact that they are having a long-term impact on the lives of the people that they're supporting. But something really important to note everything that I showed here, every single project I just showed, requires computer science skills. It requires kids to be able to code. And one of the reasons why we go to the robotics teams is that very often, far too often, they are the only kids in the high school who have ever been taught how to code. And in fact, that's being optimistic. Most of the kids in the robotics clubs still haven't learned how to code. Some of the newer teams or some of the better teams are requiring everybody to learn how to code, but a lot of them, they're on the build team or they're on the driver team. They might not be one of the kids who learns how to code, and this is a big problem. It's a problem that goes well beyond AT makers. It's a problem where we have a whole generation not knowing how to control the devices that very much control their lives, and that's a big problem. I learned to code, just so you guys know. I'm not sure how many languages I can code in, probably a dozen. But I learned to code when I was 12. I took a basic course in BASIC, which is a programming language back in the 80s. I got a computer early on, which was great, a little earlier than my friends, but not a lot of us had computers at the time. And we learned basic programming by the time we were out of middle school. We had done something of meaning before we graduated high school. I was writing software for a dentist at the time. And we very much learned early that we could control these devices. I'm not sure the kids are getting anywhere close to that today. I think these devices seem magic to a lot of them, and they shouldn't. Computer coding, let's put it that way, really does give you control of a device in a very meaningful, raw way. With that in mind, I'd like to introduce one more person to you. This is Chris Young. Now, Chris is not a teenager. He's in his 60s. He lives in Indiana, and he's a friend of ours. He's very much a part of our community at AT Makers. He is an AT user. He has spinal muscular atrophy type 2, has his whole life, obviously. And yet, he has been able to completely control his life. If there's a follow-on video, and by the way, I didn't mention this, but these little QR codes over here will take you to follow-on videos for every one of these stories. If there's one that you guys should watch as computer science teachers, this is one I'd love for you to share with your classrooms. Chris learned to code when he was young, a little bit older than me, but still in the 70s, he knew how to code. And this has been life-changing for him because Chris has made every piece of assistive technology that he uses. He's created devices to control his speech-generating device. He's created devices to control his TV and his VCR and his Blu-ray disc, whatever. He controls his 3D printer. He created the blue item you see right here. This is 3D printed that he designed and made in order to be able to control his power chair. And the device he's holding up, actually I'm holding up, it looks like he's holding it up, is called the Ultimate Remote. It's a device that he made and he programmed to control everything in his house. And it's huge. It's huge to see somebody be able to control his own life because he knows how to code. He can't solder. He doesn't have the dexterity to. I actually went out in this video. I flew out to Indianapolis for other things, for lesson fix things, and went to Chris's house while I was there and soldered up a board for him, made this sling ring, which is this device right here, because he can really only move, I don't know if you guys can see this, he can basically only move his thumb. So he actually designed his own device that lets him control 3 switches with his thumb. And between that and the joystick here, he is able to control his life. He can do that because he learned how to code and because he has stayed involved in technology. It's huge. It's something where I don't think most of the kids today, if they're ever in Chris's situation, will be able to design their own parts, right? Their own equipment to run their lives. So it's really important that we get these kids involved, and it's really important that we get them involved in not just the outreach and making the toys and making the games, but learning to code. So if I have a request or a message, please teach coding. I have some suggestions on how to get started. Obviously, one of them is use AT. It's a great motivator. If you'd like to get young women involved in technology, they're probably better engineers than men. I can think of far too few engineers I know who are women, but they are fantastic. Lamore Freed, you'll meet in a minute, is one. Lauren Merritt, worked with for years at Perot, is fantastic. But they are motivated differently, especially in their teenage years. They're not as motivated by a robotics competition, I don't think. At least not the on-field part of it. But they very much are motivated by helping somebody like Ella. I will tell you that Roaring Riptide, the folks in blue that we talked about earlier, Leanne, their coach, told me that over a 1-year period, year over year, when they added assistive technology to their program, they went from 60-40 male to 60-40 female. And the reason was the motivation, and they love it. They absolutely love what they're doing right now. Obviously, that's what I want you to do, but there are other really great ways, especially when they're younger, to teach coding. One, which I think you all probably aren't as aware of as you should be, would be physical computing. I'm going to talk about that in a minute. Another is cosplay and gaming. If you add a very small amount of logic and a very small amount of coding to a cosplay project, if you don't know what cosplay is, that's a bigger. I can't do that in 20 minutes. But if you have kids in your classroom who are into cosplay, and you'll know it, a little bit of logic, a little bit of ability to control lights or have things react to something will make a huge difference in what they're already interested in. So choose projects that are motivating and that they find meaningful. And if you have trouble getting started, if you're not sure, my recommendation would be to get to know the woman on your right. The woman on your right is Lamore Freed. She is the CEO and founder of Adafruit.com. And this is going to sound like an ad for them for a minute, and you'll see why. It really isn't. I'm not trying to make this to be an ad for them. But they are a huge partner of ours. They've been a fabulous partner. And she actually has her own mission. And her mission is girls in STEM. She wants women to be in science, technology, engineering, and math. And that's her outreach. So she has like I have a company and an outreach, charity. Her outreach very much is get women involved in technology, and she starts at very, very young. So you'll see at the bottom here, you'll see she actually has a puppet show that teaches what's a resistor, what's a capacitor. G is for ground, is that one. And so she has coloring books and things that are for really young kids. They have a program right now where if you buy one of their devices, one of these, which is called a Circuit Playground, they will donate one for one matching for Black Girls Who Code. They do Girls Who Code every year. They do Hour of Code. They very much are a part of getting coding into the schools. And the thing at the upper left is really important. So this is the device I was just looking at. I actually use these a lot. This is called a Circuit Playground, and they're smaller. I have a case on it. I should probably take the case off while we chat. But if you look, you'll see that kind of looks like Scratch, right? It looks like drag and drop programming if you've ever seen something like that. That's actually something called Make Code. And what's neat about it is it allows you to control hardware, like this one right here. Sorry about the green screen. But hardware can be controlled by dragging and dropping conditional statements, by literally dragging components from the device onto a pallet, wiring things up, and being able to code. And then interestingly, you can hit a button and you can see the JavaScript that you just created. It is very easy to use. It is very powerful. And I highly recommend that you take a look. The QR code on this page actually will take you to their educators page where you can find a great deal of information. The other reason I like bringing Adafruit up is they are a huge supporter of ours. Most of what we make is impossible without the hardware that they create. That's not an understatement. Every project that I showed, I'm trying to think through them, but it's true. Every project that I showed above requires Adafruit hardware in order to work. And I'm going to show a quick video from Lamore and Phil, her partner, about their involvement in this, and just to show they really are. It's not just that they want to support us, they love supporting what we're doing.
If you're someone who needs special hardware and you don't have that skill set, it can be very, very expensive and challenging to get that stuff made for you. But there's people in the maker community who are like, oh, you just need a really big button that sends a keyboard press to your iPad, and there's just nothing on earth that does that. And so like, I'll make that for you. And so the ability to custom make hardware, and that ties together with open source hardware, right? If it isn't open source, it's not possible to do. So having open source hardware and have it be easy for people to customize it has allowed the accessible technology community really mesh well with the maker community, which I think is very interesting.
And one note about the assistive tech. So that was a big surprise for us in the last few years. Like, we're not an assistive technology company, but when you make something so easy to use and it can be distributed to others. So there's so many things that you get when you start doing stuff with like Feather and CircuitPython that like Bill Binko from AT Makers does a lot of stuff with feathers. There's things that people specifically made for assistive technology. So that's always really neat to see. I think maybe next year, if we do another contest, we could do one for all the different types of assisted technology. Like, there's enough stuff going on just with Feather alone.
Absolutely.
I know that's a Hackaday Prize thing, but that's always good to see, because imagining what you can do with technology that can help others, and we're all going to need assistive tech one day. That was really good to see. Very, very heartwarming, and makes me have some hope.
So as you can see, they are awesome. And if you have a chance to use their products, and they have a whole learning system where for free you can get lessons and learn how to do physical computing, please do that. Also, reach out to us. We would love to help you get started. We'd love to help you get AT into your classrooms as a motivator. It's going to start off as a motivator, and what you're going to realize is it ends up being what they want to do. The number of kids who come to me in high school and say, what degree do I get to do this? Unfortunately, I don't have an easy answer for them. I say, if you can do the math, get an engineering degree. And if you can't, then there's lots of other ways you can get involved in AT, whether as an occupational therapist or a physical therapist or whatever. But they really love this. And it is something that I think if you add this to your classroom, if you add this to your computer science initiative, it will give you something meaningful and important for these kids to do without just looking at their future. It's something important to add to their present, and I hope you'll consider it. I'm going to stick around, obviously, for questions over the next 40 minutes or so, I think. And if you don't get the questions you need answered, just reach out to me directly. You can reach me at bill@atmakers.org. I'll put a link right here for my email address. Just reach out directly. Also, atmakers.org, you can sign up for information there. And if you want to follow along with what we're currently doing, what projects we're working on, join the Facebook group. I hate that it's a Facebook group, but that is where the other support groups are. That's where our customers live, and therefore it is where we live as well. But it's listed as AT Makers, Makers and Users. You'll find it if you search for AT Makers on Facebook, and I hope to see you there. Thanks.